The goal of today is to write definitions as conditional statements. And conditional statements you use all the time. They sound like, if something happens, then something else will happen. Like if you get a bad grade on your report card, then you might not be able to play sports. Or if you don't clean your room, then you might not be able to go out this weekend. Something like that. Those are conditional statements. They have a condition placed upon them. So let's go through these definitions. I've given you a lot of them. My goal is to have you write notes out in the margin and focus on key words in these definitions. First up, it says conditional statement. It's a logical statement with two parts. So that two parts is the key thing. It has a hypothesis and a conclusion. Two parts. A hypothesis, comma, conclusion is how it will generally be written. A lot of times these conditional statements will be written in the if-then form, like I mentioned earlier with my examples. So it'll say, if something happens, then something else will happen. That's what it'll look like in a lot of situations. So the if part is the hypothesis, and it matches up. If is the hypothesis. You can see that over here. They correspond. Then the then part will be the conclusion. And you can see once again, they do correspond. The hypothesis will come first, followed by the conclusion. The hypothesis, once again, is the part with the if statement. It traditionally will come first. However, we're going to be playing with these statements and switching them around here and there to see if they still remain true if we switch things around. Conclusion, once again, has the then part. We've already talked about that up here. They do match up. It should make sense. Following that, we have some other terms. We have the term negation. The negation of a statement is the opposite of the original statement. So once again, you will use words like not or didn't. Oops. Those are words that are negated. Instead of saying it is, you would say it isn't. Those are words that have been negated. You could also think about it in numbers. If I told you the number +1, the negated number would be -1. Another important word would be converse. Converse has a different word than negation. When you do the converse of a conditional statement, you switch the hypothesis and the conclusion. So the key word for converse is switch. The key word for negation, what was that one? I didn't underline it. Opposite, or not. Yeah, you could think of it as not. They use that word a whole lot. So the converse switches the order. The negation takes the opposite. The inverse does what? It negates. So remember that once again, we've talked about negation. That means opposite. That's the key word. Whenever you hear write the inverse of a statement, you should write the negation, the opposite of what it says. Good question. No, good comment. The next one is contrapositive. This is the most difficult one. This is the one that is missed most often because you can see it has a more complex definition. It actually does two things. The contrapositive of the statement is formed by writing the converse and negating. Well, once again, what does the word converse mean? Oh, switch. So we switch, and then it said, what's it do? Oh, it negates. What's negate mean? Oh, negate means opposite. So we switch it and then we write the opposite. So it's a little bit more complex. Still a good thing to be able to do. The next term is equivalent statements. Equivalent statements are two statements that are both true or both false. So underline those. Both true or both false. Some of these won't make a lot of sense until you see examples, but when you see the examples, I definitely think they will make sense for you. Let's look at some others real quick. We have some other important terms down here. We have perpendicular lines, and this is probably something you should remember from maybe middle school, maybe even elementary school. So let's see if we can remember these. Perpendicular lines, what do they usually look like? Yeah, go ahead. It looks like a what? Kind of like a T is what normal people say. Perpendicular lines generally look like that. Sometimes if you extend the lines, it'll look like that. Those are examples of perpendicular lines. And what symbol did I draw in there? The right angle symbol. That means they are 90 degrees. I wish they would have put that one last because biconditional kind of goes along with these contrapositives and equivalent statements. Biconditional statement. Biconditional statement. A lot of people miss this as well. These two, the contrapositive and the biconditional, are the two commonly missed ones. What you do is you write if and only if. So I'll show you what that looks like. We could say, if it is raining, then I will use an umbrella. Write that down real quick. If it is raining, then I will use an umbrella. If it is raining, then I will use an umbrella. Pretty simple little statement. What we're going to do is we're going to take this conditional statement, this if-then statement, and write it as a biconditional. Here's what you do. You cut the if and you cut the then. And you basically write what's there. You write, it is raining. So once again, we write, it is raining. And this is where we use that if and only if. We plug it in place of that then. I don't use a comma either. So I write, it is raining, if and only if, and I write that as IFF. That's the fast way to write it. It is raining, if and only if. That is written as IFF. I will use an umbrella. And I'll pause and read that again. It is raining if and only if and some words are kind of not needed. What can I cut out? There are two words I can cut to make it make more sense. It is raining if and only if, just one word, I use an umbrella. There's no other reason to use an umbrella unless it's raining. So once again, it is raining if and only if I use an umbrella. That's an if and only if statement, a biconditional statement, and that's how it'll look. A lot of times it will make more sense than this, but that's the key thing of biconditional statement. The neat thing about a biconditional statement is you can actually change the order a little bit. I could also take this piece and switch it with this piece. As long as I keep that if and only if in the middle, I can switch these around. And that's pretty neat. The way you'll see it on a test is I'll give you a conditional statement like this one, like this first sentence up here, and I'll say write it as a biconditional statement. So you'll take it, you'll cut off the if and then, you'll make it sound a little better by occasionally removing words, and you'll insert if and only if, IFF. So once again, this is logical thinking. It's not exactly what you're used to considering as math, but logic is a part of math, and especially geometry. I guarantee this next question on the test. It says on example 1, rewrite the conditional statement in the if-then form. So we take that statement and we have to insert and kind of reword occasionally. I like to keep most of those words, though, to make it sound like the original statement. I'll give you a little second to try that, so try that on your own. So once again, sometimes you may have to reword, add, or subtract as long as you don't change the original meaning. So once again, it says all vertebrates have a backbone. So I've already heard some good answers. I would say if an organism and don't put backbone first, so is a vertebrate, then it has a backbone. So one more time. If an organism is a vertebrate, then it has a backbone. So be careful. You don't want to say if it is a vertebrate, then it is, or it has a backbone. You don't want to use it a whole lot. Sometimes you need to start off with a descriptive word. So organism was my descriptive word, and then I broke it down from there. One more key topic. Vertebrates is the word that comes first, therefore it needs to be in your hypothesis. The backbone word comes second, so it's going to be in your conclusion. Please pay attention to that. You need to keep the order the same so you don't change its meaning. Try the checkpoints now. I'll give you a little bit of time. All right, so checkpoint number 1. It says all triangles have 3 sides. Remember, if it mentions this triangle word first, that should be in your hypothesis. The second part should be in your conclusion. So here we go. We should write if a shape is a triangle. Oops, forgot my N. Comma. Make sure you have your comma. Then it has 3 sides. That's a good answer right there. On number 2, it says, when x equals 2, x squared equals 4. It tells you what should be in your hypothesis and what should be in your conclusion. You're basically just rewriting it with if and then. So I'm going to save us a little time and just do this. If x equals 2, comma, we're going to insert this word, then x squared equals 4. So I think that's the correct symbol. You do something like that. Then x squared equals 4. That's a quick, simple answer. Example 2 has multiple parts, and these are on your test, guaranteed. So you got to make sure to read and understand this. The first thing it says, write an if-then statement. So they start off down here. They say if-then form. The next one is write the converse. So they write converse. Then the inverse and the contrapositive down here. Those are the things we're going to do with this statement. Olympians are athletes. But then we got to determine, is it true or is it false? Lots of parts to this. Let's try it together. First thing we got to do is we have to turn this statement up here into an if-then statement. Who thinks they know what that is? Go ahead in the back. Okay, so how about if a person is an Olympian, then he or she is an athlete. With that idea, you should be able to do these pretty easily. First off, let's remember, what does the word converse mean? Who can switch? Yeah, they're going to switch up the order all the time on these questions. Inverse means opposite or negate. I'll put both of them. Negate or opposite. And contrapositive. Switch and opposites. Please make sure to get that. I'll give you a little bit of time to try them on your own. See if you can do it. Here's what it should look like. So converse. That means we need to switch the order of this original if-then statement. So instead of the Olympian coming first, it's going to come second. And it's going to be switched with athlete. So here's how it should look. If a person is an athlete, then what should I say? Then he or she is an Olympian. And that's a good answer. Now, is that true? Are all athletes Olympians? No, that's a false one. Now, is the first one true or false? If they're an Olympian, then they're an athlete. That is true. If they're in the Olympics, they're an athlete. Definitely true. On the inverse, it says we need to negate or write the opposite of the original. So we're going back to the original. So what's the opposite of if a person is an Olympian? Is not an Olympian. Good. So if a person is not an Olympian. Now we got to negate the second part. Then he or she is not an athlete. Very good. Last one, contrapositive. This one is used most often. Sorry, we forgot to say, is this true or false? If a person is not an Olympian, then he or she is not an athlete. Is that true? If they're not an Olympian, then they're not an athlete? No, that's false. Last one, contrapositive. Once again, we need to switch and take the opposite of the original statement. So we're switching and negating. So please pay attention to that. So if a person is not a what? Switching, remember, athlete goes first, an athlete. Then what? He or she is not an Olympian. Very good. Now, is this true or false? Read carefully. If they are not an athlete, they are not an Olympian. That's a true statement. So once again, the if-then was true, the converse was false, the inverse was false, and the contrapositive true. Now, this will not always keep this same pattern. So you need to be aware of switching things around a little bit. This next definition is about perpendicular lines. It says if two lines intersect to form a right angle, then they are perpendicular lines. Or you could say 90-degree angle. I would take either of those. The definition can also be written as the converse. What's converse mean? Switch. So remind yourself, converse means switch. We can switch the order and is still a true statement. So if two lines are perpendicular, then they intersect to form a right angle. Good job. And then they shorten things down a little bit. Line L is perpendicular to line M. And that's the symbolic way to write it. Now I like that. That is the perpendicular symbol, the upside down T. They name these lines with the italic letter in the corner or cursive letter in the corner too. What we're going to do is we're going to use these definitions down here on example 3. Let's read it real quick. Decide whether each statement about the diagram is true. Explain your answer using the definitions you've learned. Here's the first one. AC is perpendicular to BD. Is that a true statement? AC perpendicular to BD. Yes, that is a true statement. And how would you say that? AC is perpendicular to what other line? BD. Because they form Because they form a right angle. So I'm kind of abbreviating. Because they form a right angle. That is the reason why. The next one, please pay attention to it. It says some different stuff. AED, and I'll highlight it. AED and BEC. So AED and BEC are a linear pair. True or false?
Right.
Are they stuck together sharing a vertex? Yes, they do share a vertex. They share E. But do they share a ray? Are they adjacent? No. So this is a false because the two angles are not what? What's that A word? They're not adjacent. They're not adjacent. If they're not adjacent, stuck to each other, share the same ray, then they cannot be linear pairs. Example 4 has two parts. It wants you to take this definition right here, and it wants you to write it as a converse and as a biconditional. Let's write out to the side, what does converse mean? Switch. If you're not getting that by now, you really need to study. And what does biconditional mean? What should you have for that biconditional? Okay, so you cut, write this down. You cut the if and the then and write IFF in the middle. That's the key process for writing a biconditional. Try it on your own real quick. Okay, let's see how you did. Here are the solutions. So the converse of this original statement, we switched the order. So I wrote, if two lines are parallel, I use the symbol, then they lie in the same plane and do not intersect. That would be a correct answer. For the biconditional statement, we cut the if and the then on the original. We cut the if, we cut the then, and we insert if and only if. So, let's see if I did that correct. Two lines lie in the same plane and do not intersect. Yep, we have that. If and only if they are parallel. Now, is there a comma needed for the if and only if? No comma needed. Make sure you don't have a comma there. Is there one needed for the converse? Yes, if it has an if and then, it needs a comma. Good job. One common mistake on the converse is to say if they are parallel. We can't say the word they because we don't know what they is talking about. They is not a descriptive word. We actually had to steal the two lines because that was the descriptive part of that original statement. That's what we're talking about. So you need the descriptive word, and then later on you can say they, like we did down here. So please be careful about that. They comes next. The descriptive word comes first. Try these two checkpoints on your own. See how you can do. Read carefully. Here are the solutions for checking yourself if you want to look over these. Once again, remember the if-then must start with an if, followed by a then, separated by a comma, and you keep them in the same order. So if they said squares comes first, it should be in the hypothesis. Converse comes along and it switches the original statement, so the rectangles will come first, followed by squares. They still have an if-then. Inverse will negate or take the opposite. So there's that negating word on that first word, square. Same thing on the second part, not a rectangle. Last part, contrapositive. You switch and you negate. So you say, if it is not a rectangle, remember rectangle is switched order, and then it is not a square, switched order again. Last thing you need to look at is number 4. Analyze this answer real quick. It says, decide whether each statement is true. Explain using definitions. So in this picture, it says, angle GLK, and it's good to highlight it, GLK and JLK are supplementary. Is this true? Yes, this is true because they are a linear pair. The next part talks about some other pieces. It says line GJ and line HK are perpendicular. That's what that symbol means. They're perpendicular if and only if they have a right angle. Do you notice a right angle? No, that's why this one is false. Last little one is number 5. Didn't give much time on this one, but here it is. It says write it as a biconditional. So remember, the key parts of biconditional would be to take off the if and take off the then. But they don't have a then. That's the problem with this one. So you got to analyze it in a little different way. What you do in this case is actually really neat. If you see a repeated part, then you can actually cut it out. What they do in checkpoint 5 is they say write the statement as a biconditional. So they actually write the statement twice. They write the if and the then, and then they do it again, and they switch order. Really, you should do this. This is a good practice, but I'm not requiring it all the time, to write them in the Converse, the original and the Converse. But anyways, if you just focus on this one, you should still be able to write the biconditional. They wrote it actually from the second one. So they say if a student's in group A, then the student must be a boy. So they just cut the if and inserted if and only if right there. You can see that. The if and only if goes right there after the A. They don't have if, they don't have then anymore. Pretty good one.